this is topic 7 of computer programming, believe it or not. Where did the time go? And this topic is about dictionaries and functions. So dictionaries and functions, a couple of the more abstract data structures in Python compared to a simple data structure like a string or a variable. So first of all, dictionaries. Now in computing we have this concept of key value pairs. Okay, now a key value pair is sometimes called an attribute value pair, a field value pair, a key value pair, a name value pair, something value pair basically. And what it means is you have this key and you have a value. Okay, so here is an example of a simple one I have. Name John, age 30, car null. Okay, and what we're actually doing is we have some attribute and then we have some value associated with that attribute. So in Python we have this way of mapping a key to a value with a mapping data type called a dictionary. Now in other languages these are called key value stores. There's other things, they're called associative arrays, there's a hash map, all sorts of names for a key value store, but basically they all follow the same structure. So I have created a dictionary here, test results, and I've got 3 people, Hopeless Helga, Big Jimmy and Clueless Charlie, and then the grade that they got in the test results dictionary. So the key would be name and the value would be score in there. So here's another dictionary I've created about a pair of trainers, or trainer dictionary we'll call it, shoe dictionary. So my dictionary, and then to open it in a list we use the square brackets. For a dictionary we use these rounded brackets, curly braces, curled braces, curly brackets. And we have colour, brand and model are the keys, and black, New Balance and 373 are the values. So those are the values, and then when we want to print we just print my dictionary. So let me just copy this over and let's have a look at what it looks like in Python. So let's just paste that in there. So there's the dictionary, and if we do print my dictionary, it will print out all of the content of the dictionary. Now, how do we go in and access specific parts of the dictionary operations? We can get the value out by calling the key. Okay, 2 ways. We can either call it by its name or just do mydictionary.get. Okay, and we can actually change values in the dictionary by calling the key and saying equals and applying a new value. Okay, so there's a few different ways that we can do this. We're not limited to, there's no real strict way to do things on the dictionary. So we can loop over a dictionary just like we can with a list, and we can go into a dictionary and we can look at the different keys and values. Okay, so let's have a wee look at an example for key value in my dictionary.items. Print key value. Let's have a look at that one in action. So for key and value in my dictionary.items, print key and value. So that would print out the key and value. Okay. Now, if we just want to print, so let's have a look at another example for, let's just say for item in my dictionary, print item. Let's just go print item, and we'll take away the my dictionary.items. Let's just see what happens when we just run it as if it was treat it the same way as a list. Okay, so that gives us the keys. If we want the values, we just do mydictionary.values, and that gives us the values. Okay, so If we just print it like it's a list, we get the keys. If we want the values, we just put dot values. If we want both, we can do key comma value, print key comma value. Now, these don't have to be key and value. These could be elephant and cat. Like these are just temporary variables for iterating over the dictionary. Okay, sometimes you might see these written as like very shorthand. People sometimes do KJ or KV, say. That means key and value, right? If they're doing K and V, so KV. But you wouldn't want to write a whole program where everything was K and V, because then when you came back to it later on, you'd be like, what's K again? Which key of which dictionary? Another thing you'll often see is for I. Okay, now I could be short for item or iterator. Okay, now if they're using I, they might use IJ. Okay, for IJ. These are just like throwaway values that people use for demonstration. Okay, so you might see I, you might see IJ, you might say KV, but it's probably easier to write key value, because then there's no question about which is the key and which is the value. So that is the dictionary data type. Now, there is such a thing as an ordered dictionary, okay, and dictionaries are technically ordered now in Python from Python 3.7. You could have a dictionary where the key was 1 and the value was someone's name, the key was 2 and the value was someone's name. Okay, you could have it numbered like that, but why would you want to do that when you could just have a list and the list's already indexed? Okay, so one thing to note about a dictionary is it's not indexed like a list. Okay, so let's go back to my for item in my dictionary, print item. If we wanted to call, say, the first item, this one here, if we do that, right, okay, it's going to give us like a strange, like, it's going to give us like it's going to give us the first thing on the index of the name of the value. Okay, so the dictionary isn't really truly indexed in the way that a list is. Now, just to remind you, if we make a list, right, my list equals, and we just put 1, 3, 6, 8 in there, and then we save that, and then if we do print my list, now let's say we want to get this last value out, okay? Count the index, 0, 1, 2, 3, that would be the third index position, so we just put 3 in there and it'll give us back the 8. Okay, so the kind of thing to know, or the way to differentiate the two, is that the dictionary is a set of key value pairs that are mapped to each other, and the list is an indexed data type where we can pull things out, but not key value pairs. Okay, in a list, it's just a list. Okay, so that's the dictionary data type. The next Python topic is functions. So sometimes when we're writing a program, we might want to do something quite regularly. Like, let's say we were writing some kind of tax calculation program. National insurance, I believe, is 8% at the moment, although I think they're going to hike it. So let's say we had to always keep working out what 8% of something was. We could write a function to do that, and then that would save us having to write out code all the time. So when you have some sort of operation or procedure in the program that you do more than once, or that gets used regularly, a good idea is to put it into a function. So how do we actually create a function? Well, we create a function using the word def. Okay, def just means define. Okay, so this is the most simple function we can have, or the most simple one I can think of anyway. So let's just define a function. So I'll just clear off the dictionary stuff. So here we've defined a function called myFunction. Okay, and myFunction is going to perform one thing. It's going to print hello from a function. Okay, so when we define it, we type def, then we write my function, then we open and close curly brackets, then we press the colon, press return, and then we put whatever's inside the body of the function in there. So let's send that over to the RAM there. Now, let's say later on we want to call that function, we want to summon it. All we do is we type the name, and then we put these two brackets like that. And that calls it. It's called calling the function. And if we call it, it'll run whatever's inside here. Okay, so this, we can put more complicated things in here. This is just the simplest example that I can come up with. So the open and close rounded brackets that we use in the function, we can actually place in there things, okay, and these things are called parameters. Okay, now a function can take multiple different parameters. So let me just give you an example. Let's go back to my function again, and we'll put in here x and y, and those are going to be the formal parameters of the function. Okay, the formal parameters, and then inside the body of the function, rather than just saying print, I'm going to say return x plus y. Okay, so let's save that to the RAM. Now, if I call my function again, it's going to give me an error, okay? Because it's going to say two positional arguments were required, x and y. So this function, it's waiting for two things. So let's call my function again, but give it two numbers, so 5 and 6. And what it's going to do is it's going to return the sum of those two values. So let's run that. So there. So now we've created a function that does addition. Okay, now I know we could easily just do 5 plus 6 like that. But let's say we had some slightly more complicated mathematical calculation to do. We could put that into a function and then just send values to it. Send them from here as arguments. Okay, so when we send them in, they're called arguments. When we define them in the function, they're called parameters. Okay, so this function, the proper terminology for this is the function has two formal parameters, okay, and it will take two positional arguments that it will then substitute inside the body of the function for those two parameters. Okay, so let's have a look at something a bit more advanced. Here is a program that will convert Celsius to Fahrenheit. So this is the formula. You have to do 9 divided by 5 times the amount in Celsius plus 32. Okay, so let's just copy this into the computer. Let's just clear that. So we're going to create this program. Celsius is equal to integer input, enter temperature in Celsius. Then we've got this calculation, and then we've got print the temperature is this, which will be the result of the calculation. So let's run that. It's going to say enter a temperature in Celsius. So I'm going to say, okay, it's 10 degrees. And then what's going to happen is the program is going to calculate 9 divided by 5 times this plus 32, and then pass it to that variable, store it in that variable, and then print that out. So let's run that. So apparently if it's 10 degrees, it's 50 degrees Fahrenheit. Fantastic. Now that works just quite well as it is, but let's say we were doing a lot of these calculations. Let's say we had to do this 20 times in a program. We wouldn't necessarily want to write this out 20 times. So what we can do is we can put this calculation into a function, and then anytime we need to do the conversion of temperature, we can just call the function and pass the temperature in Celsius to the function as an argument. Okay, so we'll create a function that takes one formal parameter. It receives input of Celsius, and it will return the output in Fahrenheit. So let's go back and have a look how we can do this. So here's the example. So we'll define a temperature function that takes one formal parameter and will return this. Okay, so let's just see that in action. So instead of having the code written out like this, we'll do define, okay, my temp, let's call it temp convert, temp conv, okay, and then that function's going to take one formal parameter, make it X to make our lives easier. Oh, let's make it C for Celsius, and that's sensible. Centigrade. Right, then we press return colon, just like we do with if statements, for loops. Press return, and then we're going to say, like, okay, so what do you want me to do with this formal parameter that you're going to send me when you call me later on? We want you to return the 9.0 divided by 5.0 divided by C, no, times C plus 32, and that's going to give us the value in Fahrenheit. Okay, so let's save that over to the RAM. So now we have a function called temperature convert. Okay, so let's go back to our previous program. Looks like this. So instead of having this line, we don't need this line anymore because we have that stored in a function. Okay, so we have that stored in our temp convert function. So let's get rid of that. Okay, and now we have these two. We're still going to input Celsius, okay, but instead what we're going to return, okay, is, well, let's take away this my temperature is to make it a bit easier to read, okay, and we'll take away that to make it a wee bit easier. Enter Celsius, there we go. So print, right, so what we're going to print, we're going to print the result of my temp convert, and then what we're going to do is we're going to open up the rounded brackets and we're going to send something to the temperature conversion function. Okay, so what are we going to send? We're going to send Celsius, and then Celsius, if I could spell it, it's like a Latin word, that, isn't it? Celsius, right. So we're going to send that into this function and it will be substituted over as an argument with this parameter, and then inside the body of the function this will happen. So let's see what happens now when we run this. Enter Celsius, right. Let's say it's going to be 10 degrees, as it often is. Okay. Enter. I knew I've spelt it wrong, haven't I? Celsius is not defined, right? Celsius.
You put the C from S in Celsius.
C. Ah, yeah. Been studying too much Spanish, haven't I? That is a typo. It should be C there, shouldn't it? Right, there we go. Try that. Right, 10. There we go. Then it comes back with 50. Alright, if you can spell. You have to be able to spell the name of the thing that you're trying to convert. If you can't spell it, then you've got a problem. So I don't know, is it Celsius with a C? Celsius with an S? This is one of the confusing things about Latin languages. Why do we have this issue where we have S, C, and then sometimes even in French and Portuguese they have the C with the little tail on the bottom of it, which is also like an S sound. Just a little bit confusing, isn't it? And then you have the other issue with C can also be like a K sound, but so can K and so can QU. So which is it? Who knows? So there we go. Ambiguity for us all. Right, so that was how we define a function. A point I want to make now is that we've been using functions from day one. Okay, here's all the functions that are already built in to the language. So we've been using things like, where are we? Print from day one. Okay, print, we've already been using print. We've used len, it'll be in here somewhere. Len, the length. So these have these rounded brackets, just like we created in that Celsius function. So when we do print, okay, print, okay, that's a function, and print's job, okay, it accepts arguments, hello there, and it returns them back to the screen. So print is a function that we've been using from the beginning, and we've got all these ones built in, things like min, max, they make sense, they're used all the time. Okay, float, int, things like that. So those are the two topics for today. Okay, now there's one more little bit that I wanted to talk about, and that is modules. Okay, now modules, sometimes you'll hear me calling them libraries. Now, Python comes with these built-in tools, but Python is a general purpose language, which means that you can use it for lots of different things. So Python can be used for medical research, Python can be used for cybersecurity, Python can be used for data science in finance, or data science in chemistry, physics research. Python can be used for a wide variety of different things. It can be used for application development, web development. Now, out of the box, it just comes with a basic set of tools. So sometimes we might want to add new functionality to it. And the way we do that is we add new modules to our Python install. So we add a module by downloading it from the internet. So if I go over to Jupyter Lab here and do a new terminal, so on Windows this would be the equivalent of opening up CMD. Okay, start CMD, start run CMD, or start command prompt open, right? So you can do it from Jupyter as well. Jupyter will let you open a CMD shell. Okay, now there's when you're using Linux, or when you're using Debian-based systems like Ubuntu or Kali or Raspbian and Debian itself, to install software you do apt install or apt search, and you can search for something like, let's search for calendar, right? Apt search calendar. Okay. So what it's going to do is go on the internet and find all the software that has the word calendar in it, and there's going to be all sorts of stuff. There's a calendar widget for Python, client for Microsoft Exchange, Python, all sorts of stuff. So Python has this functionality as well, and we have this tool called Python install package. So if you want to install something, you just type pip install, okay, and it's going to go on the internet, it's going to get something. So I'm going to tell you about a popular library today called pyplot. So pip install, the full fancy name for it is matplotlib.pyplot. Okay, well, you can just do matplotlib actually. It's going to tell me that it's already satisfied. Right, requirement already satisfied, because I've already downloaded that from the internet. So the next thing I'm going to want to do, okay, is I'm going to want to load that into my Python program. Okay, so I'll just grab this as an example. Let's just do Control C on that, and we'll do back to the console, and we'll do clear. So let's say I want to import matplotlib.pyplot. Okay, I can just import it and call it, give it a nickname. Okay, so we just use this keyword as, and that's called an alias. And then here's a couple of lists, and then what I can do is I can use plt, okay, matplotlib.pyplot, and I can use the bar function from that, and I can pass these two lists into there. Now let me just change height to category, because otherwise I won't. So let's see what happens when I run that. So there, it gives me a bar chart. Okay, now the point here today is that Python doesn't have this functionality built in out of the box. So we have to go and download a module from the internet that will give us this functionality, okay? Now, the reason that it works like this is because depending on what you're using Python for, you're going to need different libraries, different modules, okay? So there's just a basic example of some third-party functionality that we can add to Python. Now, so when we want to add it to our script, we have to download it first of all from the internet, and then we just say import and then the name of the module. Then we can get use of all the functions, all the functionality that's available in that module. So here's a couple of examples. Import time. So time is a module. So by default, you probably can get Python to read out the time, but it's probably in a horrible format. You can use the ctime library to print out the date and time in this nice way here. Okay. Then there's another library called hashlib. Hashlib it's used in cybersecurity. It's just for doing MD5 hashes. So we'd have to go online, download it if we didn't already have it installed, import it into our script, and then we can just run hashlib.sha256 on something, and it'll give us the sha256 hash of that. So that's just the important modules. So what I'm going to do now is stop the recording and just see if anyone wants to ask any questions about any of those topics. So we have key value pairs, dictionaries, functions, and importing libraries.